Hello engineers, welcome back to Engineering Design Simplified. In this video series, I will be solving tough engineering mechanics problems. If you want to watch more videos like this, please subscribe to my channel and press that bell button so that you will be notified when I upload a new video. In this video, I am going to discuss nail gun problem using impulse momentum method. So there are many types of nail guns in the market. In this picture, a cross section of a pneumatic nail gun is shown here. So this is the piston, this small black line. This is a piston and this is a nail here, and this is the nail magazine. So the piston of the nail gun hits the nail of mass m kg with an average force F newtons for a duration of t milliseconds. Immediately after impact, the nail gains a velocity of v2 meters per second and penetrate into a wooden block to a depth of x millimeter against the resistance of the wooden block of r newtons. Basically here the piston hits the nail and nail is shot into the wooden block like a projectile. Let's see in the coming slides how to deal with this kind of problem. First let us see impulse momentum diagram for the nail. So initially the nail of mass m with the initial velocity v1 equal to 0 meters per second, and during the impact the hammer hits the nail with a force of F for a duration of ti seconds. So after impact, the nail gains a velocity of v2 meters per second. So the initial momentum of the nail is m into v1, so that is written here, and the impulsive forces, only force that is acting on the hammer is on the nail is the hammer force for a time duration ti. So that is impulsive forces on the nail can be written as integral of F into dt, and final momentum of the nail is its mass into its final velocity v2. So that is written here m into v2. So in this equation v1 is 0, so this will become integral of f dt equal to m v2. So from this we can find velocity of the nail after impact or just before penetrating into the wooden block. V2 is equal to F into T by M. F is the force on the nail and T is the time duration and M is the mass of the nail. Now let us see depth of penetration, that is X. So using work energy equation, work done against the penetration can be written as R into X. Here R is the average resistance by the wooden block and X is the depth of penetration. So R into X equal to change in kinetic energy. Here the initial kinetic energy of the nail is half into m into v2 square, and the final kinetic energy, that means it will come to rest. So final velocity will be 0, so that term is not written here. So work energy equation can be written as R into X equal to half into m v2 square. So from this we can find X, that is the depth of penetration, equal to m v2 square by 2r. So here m is the mass of the nail, v2 is the velocity of the nail just before impact, just after impact, and r is the average resistance by the wooden block. So for the given average resistance of the block, if we increase the force on the nail, it will increase the velocity of the nail, and that means the depth of penetration can be increased. That's all for today's video. If you like this content, please like, share and subscribe. Thanks for watching.